So in this problem, we have a piston cylinder device initially contains 0.5 kilograms of argon. So we can consider argon as an ideal gas at an initial volume of 0.075 cubic meters at a pressure of 600 kilopascals. The piston position is now adjusted by changing the weights until the volume doubles. So there is an expansion process and it doubles its original size. So we already know that V2 should be equal to twice V1. While heat is removed to keep the process isothermal. So we know now that T2 is equal to T1. What we need to get the final pressure after this process, and we are given the gas constant for argon. Okay, so this is problem 3.4. Let's sketch the problem. What do we have? We have at state 1, we are dealing with a piston cylinder assembly with an ideal gas here. In our case, this is argon. And what do we know? We know that the initial volume V1 is 0.075 cubic meters. And we know that the pressure P1 is equal to 600 kilopascals. Now what do we have? We have on the top of this piston, we have some weights, okay? And then what we will do, we'll remove the weights, so there will be an expansion process. So the piston will move up, leading us to state 2. Here I'm assuming we remove all the weights, but it's not necessarily the case. We still have our argon. And what do we know during this process? We keep the temperature constant. So T2 is equal to T1. And we know that the volume has doubled. So V2 is equal twice V1. And what we are looking for P2, okay? Again, so here we have a piston cylinder assembly. It's a closed system. What do we know? We know that the mass 2 is equal to the mass 1. So therefore, let's start from this. So we can write that M2 is equal to M1. Are we dealing with an ideal gas? Yes, we are. So therefore, P2, V2 over RT2 is equal to P1, V1 over RT1. So now there are different ways actually to solve this problem. The way we're doing it will be like the more systematic one, which is like I will write out the expression and then you will see that the solution is quite straightforward. We have the same gas, so are we dealing here with an isothermal process? Yes, we are. So T1 will disappear with T2. So then you will see that rapidly we can end up with a compact formulation, which is P2 is equal to what? Is equal to V1 over V2 cross P1. Do we have a relation between V1 and V2? Yes, we do, because V2 is equal twice V1. So therefore this ratio is 1 over 2. So this implies that P2 is simply equal to half P1. Since our P1 is 600 kilopascal, so this will give us 1 over 2 cross 600, giving us our P2 to be 300 kilopascals.